bending operation video and first video on the topic of bending up sheet and plate. So you see this my video, and now we move the minimum bend radius. What is minimum bend radius you apply in bending operation? Here I am discuss. Friends, in this section you see this outer fiber having, in bending operation, outer fiber having tension and inner fiber having compression. So what is tension and compression? True stress in tension and compression. Friends, you know, strain, outer strain equals to inner strain equals to 1 divided by 2r divided by t plus 1. R equals to bend radius, T equals to plate thickness or sheet thickness. So outer strain and O and EI denoted as inner strain. So inner strain and outer strain value is this. Friends, know this is a bend length, this is a bend length L. Bend length L equals what, saying this? Friends, due to the shifting up neutral axis, due to shifting up this neutral axis towards the inner surface, the length of bend L is smaller in the outer region than in the inner region. Friends, again you hear my friends words. Due to the shifting up neutral axis toward the inner surface, the bend length L is smaller in the outer region than in the inner region. That means LO, this is the outer length, bend length of outer region is smaller than bend length of inner region. Friends, this phenomena can easily be observed by bending a rectangular eraser and notice how the cross section distorts it. You notice how the cross section distorted. Consequently, the outer and inner strain are different, with difference increases with decreasing R by T ratio. What is saying, friends? Friends, in simple words, difference between these outer and inner strain increases if R by T ratio decreases. This is a whole concept. Friends, also in this equation, if these values decreases, then this value is also increases, and there are differences shown. Friends, the R by T ratio decreases, the tensile strain at the outer fiber increases, and the material may crack after a certain strain reach. Friends, you see here, if R by T ratio decreases, then tensile strain at the outer region increases, and at a certain portion, when the strain reach, then the material may crack. Friends, the radius R at which a crack appear on the outer surface of the bend is called minimum bend radius. If this decrease, then this is increase, and after certain value of strain, the material will be crack, and this minimum radius, bend radius, is called. This phenomena where crack is observed, then this is known as minimum bend radius. Friend, the theory is minimum bend radius is the radius R at which crack appear on the outer surface of the bend. It is called minimum bend radius. You see this. The minimum bend radius to which a part can be bent safely is normally expressed in terms of its thickness, such as 2t, 3t or 4t and so on and so on. Thus, for example, you take an example, a bend radius of 3t, a bend radius of 3t. What it can say? This indicates that smallest radius to which the sheet can be bent without cracking is 3 times its thickness. It means 3t what indicate? It means smallest radius to which the sheet can be bent without cracking is 3 times its thickness. Friends, for low carbon steel, minimum bend radius equals to 60 for hard material and 0.5t for soft material. Take example, if T equals to 5 mm, if a material having thickness 5 mm, then what minimum bend radius? minimum bend radius will be maximum for hard material 6 multiply 5 30 mm. You take 30 mm of radius. This 30 mm you safely bend without cracking, and for soft material this will be 0.25, and for soft material 5 multiply 5 2.5 mm radius will be used. In this case, for soft material, if you use 2.5 mm bend radius, then it will be chances that material no crack. This is a safe bend radius. For minimum bend radius, friends, this is an experimental data. You see on this display, you see this table. This is a experimental data. Friends, study have also been conducted to establish a relation between the minimum R by T ratio and the particular mechanical property of the material. One such analysis is based on the following assumptions. It having some assumptions. The first assumption is that, friend, the first assumption is the true strain at the cracking on the outer fiber in bending is equal to the true strain at fracture of the material in a simple tension test. So E naught equals to fracture strain. Now the second assumption is the material is homogeneous and isotropic. The third assumption is, friend, the sheet is bent in a state of plane state. That means what? That means L by T ratio is very small. This is a third assumption. Friend, now formula is the true strain at fracture in tension is epsilon F fracture is ln A naught divided by AF initial area divided by final area equals to ln 100 divided by 100 minus R, where R is the percentage reduction of area of the sheet in tension. Okay. Friends, true strain of outer surface equals to ln 1 plus E naught, 1 plus strain at outer fiber. You see this value taken from here, and after calculating you got this value will be equals to this. So this is your main formula. Friends, in first assumption, epsilon naught equals to epsilon F, both are equal. Then after calculating this you got from this is the second equation and this is your first equation. So after equating these two equations we got the value of what? Minimum R by T ratio equals to what? 50 by R minus 1. This is theoretical, but friends, in practical this value is taken as, in practical this value calculated as R by T equals to 60 by R minus 1. This is theoretically, but with practically we use this value. Friends, this R by T ratio approaches 0. If this R by T ratio approaches 0, then it is known as complete bendability. If R by T approaches 0, then it is known as complete bendability. What is bendability? We discuss next video. So complete bendability, that means what? The material can be folded over itself. The material can be folded over itself like a page. This is a page, like this page, complete folded like this. Friends, at tensile reduction of area of 50%, this percentage is the same value obtained for spinability of metal. That is, a material with 50% reduction of area is found to be completely spinable. Okay. So in next video we discuss factor affecting bendability. Next video. What is this graph shows, we also discuss in next video. So friends, I hope you enjoy this. Thank you.